Hey everybody, welcome to the channel. Today we're going to be talking about the 1.2 meter 4 servo wing. Please hit the like and subscribe button. When we get to 1,000 subscribers, we're going to start doing subscriber giveaways. So the 2 and the 4 servo wing are the same basic length and airfoil layout. They also fit to the fuselage in exactly the same way. However, the control surfaces and the panel layout is a bit different to accommodate the placement of the different servos. It takes about the same amount of time to print out and is approximately the same weight as the servos. It includes the stiffened leading edge and incorporates carbon supports for strength. The 4 servo wing mates up with any of the fuselages. This is the V-tail pica. It can also be mounted on the cross-tail rough gin or the T-tail variant. So the 4 servo wing is available with all the models and or by itself if you'd like to purchase it separately. Then you could have the 2 servo wing and the 4 servo wing and mix and match as you wish. Alright, let's get started building. In the included instructions, there's a chart on the second page with all the parts that need to be printed with print time and print weight in Cura. In the assembly diagram, there's a center, a root, a mid, and a tip panel of each wing half, along with the servo covers. The print settings are in the appendix at the end of the instructions. Bring in the part to Cura that you want to print. Make sure all of the settings are set correctly. Check that the Z-seam is at the back as it should be printed. Slice the part. And then check the part to make sure that it's sliced correctly. Make any adjustments to the settings as necessary. You can check the print time and the print weight down in the right corner. Make sure that they match closely with what's in the chart. Save it to disk and get it ready for your printer. So this is a Creality Ender 3. You can use an Ender 3 Pro or Ender 3 version 2, but they're a bit more expensive. This is the low-cost Ender 3. It is perfectly capable of printing all the pieces for any of the SoarKraft models. However, it is a bit noisy, so I've moved it out into my shop, so I don't have to listen to it. This printer, you can buy it off of the Creality website for $155, plus shipping. Because this machine is lower cost, there's a few more things you have to do manually, like you have to put it together. You have to tighten the belt. And you have to do setup. You have to manually level the print bed. But it's not that difficult, and there's lots of information online about how to do all of that. you have to have a well-running 3D printer to print good parts. The Creality Ender 3 is capable of printing in other materials. PLA is a very simple material to print with, and it does a fabulous job. It can also print PETG, it can print PLA Pro, it can print, this is lightweight PLA, it may even in PETG. But once you get the printing figured out, it's just a matter of putting material in, dialing in the part you need, and press and go. Artillery Sidewinder X1. It is a fabulous machine. It's about twice as expensive as a Creality Ender 3, but much bigger build volume. It has a volcano hot end, therefore you can run much higher temperatures and have much better control and retraction. This printer is a bit of an overkill, but it is such a nice machine and so easy to set up. And I like it so much, I got a second one. Alright, so with the file set comes an assembly drawing and set of instructions. Okay, now that you have all 12 pieces printed out, you'll notice that with the Servo Wing, the setup is a little bit different. The center panels have a section to it that the interior flap servo lives in, and the root is a little bit further out. Oh, so these are raw printed parts. We need to clean up the brims and get the hinges activated. These are my favorite tools. This is a chainsaw file that's sized perfectly for cleaning out the 6mm spar hole, and it goes all the way through. Very convenient for that. And then other file for being able to clean out any of the easily being able to clean out any of the gaps for the other carbon. So we'll clean up these parts, and I'm going to add a little bit of paint to them. Also need to cut my carbon support pieces for my flaps. There's a flap stiffener as well as an aileron stiffener, so we need 2 of those. We're also going to test our servos to make sure they all work before we put them in. To complete the wing, you'll need a 6mm carbon spar, either a tube or a rod, and 2 1-meter long pieces of the 4mm by 1mm. We're also going to use some servo extensions that will connect to the outer servo and feed through and extend the servo wires into the fuselage. Alright, let's build stuff. So this file is not only good for doing the cleanup on the 6mm spar hole, it's also been very effective in cleaning up the residual of the brim, as well as if there's any extra material that may have come up that's on the surface and it's bugging you and you want to get rid of it, you can just run it over it. It's sharp enough, it takes off the high spots, but it doesn't really affect the area around it. You just lightly And it's easier to do this before you activate the hinge. And you can also clean up the trailing edge if there's any kind of a bump. Doesn't take much. Shouldn't take more than a couple minutes to clean up each part. If it's taking longer than that, then might be something wrong with your print settings. And you should reevaluate your print settings. Like this one, you can see that as the print got near the height of the print, the part was wiggling a little bit, and it didn't quite get the best alignment once it got to the higher edge, because it's sitting on the printer like this, and the top is wiggling around. Reason to have good bed adhesion. All right, put some black stripes on the bottom of the root and the mid panel, and added some color for the wingtip. Now I'm going to activate all of the hinges. For more information on activating the hinges, check out the link in the corner here for all the information on hinges. These hinges are a little bit narrower to work with, but you activate them the same way. A little bit of filing on the inside surface and then fold away from. And keep activating it. Adding a little silicone to the PLA makes them last a good long time. PETG and lightweight PLA seem to not need to have any extra support. This is the centerpiece. So the servo wire starts the servo pocket. You can kind of see This white material you can kind of see through, and it ends up in the right place. You can also use a guide wire or something else to cram in from this side and pull through with a hook. But it's not that far, so it's not that difficult. It's not nearly as hard as the other section. Extension wire goes through this side. Servo ends up on this side, and this is so that the wire can pass by easily. We'll do that when it's assembled. So I'm attaching the servo wire to one of the flat carbon strips, and then feed it into the pocket. Taking place. Ready to start test fitting. Got center mark set up on our spars so we know where the center line is. Alright, so now that everything is together, we'll check the gaps. Alright, everything fits reasonably well, so we can take it apart and then glue it back together. Alright, I'm going to start gluing things together. Got our center mark lined up. Start with putting a little tack on this one. Alright, so I'm going to make sure that the carbon is straight. Both sides. I'm going to glue this section. Alright, so we're going to let this dry so that when we put the other pieces on, we don't have an issue with gluing things that we don't want to glue. flap carbon, tack it in place. Okay. Alright, so we're adding some CA carbon strips. And then push it together. Make sure the leading edge is where you want it to be. Aileron. Put 3 or 4 drops of CA down each of the carbon channels. So we're dripping some CA down the carbon, and get ready for the next piece. Make sure the alignment's good. Alright. We'll come back and really secure the aileron in a minute when we do the surfaces. Alright. Let's do the other side now. And we're gonna drip, 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 and easy drip, drip, and drip. So these clips are available at office supply stores. And very handy. Clipped on, makes the trailing edge of the control surface line up correctly, so we can tack it in place. We're also going to make sure the carbon is well secured. You don't want to glue the clips on, so be careful about that. But this is how we get our controls to work properly. I got the flap deflected so I can drip. Alright, so all the gluing is finished. I might do some more gap filling and some touch up here and there, but for the most part the gluing is complete. But right now we can do the silicone hinges while it's drying, or after it's dried. If you want to know how to do silicone hinges, look at the link here for how to do silicone hinges. And since we're going to want these flaps to deflect like full 90 degrees so we can get maximum deceleration in landing. So in the instructions it talks about hooking up the aileron wire to the extension while you're gluing it. When I got the glue out, I like to just glue, and when I'm done, stop and let it dry. Really not that difficult to do after the fact. Connected my aileron wire, and I'm going to just pull it in. The extension connector to be in that pocket there. Takes a little bit to get past the other wire, and you want to pull too hard. A little bit of printed material that gets in the way. There. Now its connector is about right there. Everything sits in fine. Do that for both sides. And now you're ready to connect up. Now that all your hinges are ready, all your servos are in the right position, you're either ready for your fuselage, or you can just get out your receiver and hook up so you can finish installing all the servos. I'm going to be using double Z-bends, but you can also do a Z-bend with an easy connector at one end and put the easy connector out at the control surface. The interior ones, I'm going to be using a 55mm Z-bend piece. So you want to connect up your radio, get your servos so that they move in the direction that you want, and they're centered for where you want to put the servo. And on the very last hole in my servo horn. Okay, and you just need to get it about where you want it to be, and then we're going to pin. We'll get to that in a second. And we're going to put this one on fourth one. If you do the same thing on both sides, then your movement of your servo should be balanced. So I've been using hot melt to hold my servos in place, just in case a servo happens to fail. Makes it a lot easier to replace. Also, don't use CA, especially the thin CA, to hold the servos in place, because the thin CA has a tendency to get inside the servo and glue it. So with the control surface pinned in place with the clip, servo is in its center position. I'm just going to tack. Okay, once you got the control horns on and the push rods where you want them, make sure you don't forget the screw that holds the horn to the servo. Again, another reason why I use hot melt. If you screw this up, you can fix it. Put a little hot melt in the corner to tack it in place. All right, now we're going to attach the servo cover to the servo. So you can hand drill or use a power drill to Drill some pilot holes. Don't need much to get through this, but these screws, just a little bit of added insurance to keep the cover from sliding around, delaminating, or anything like that. They're essentially holding the position of servo, and you don't want it to move. Alright, so you want to check the CG of your wing once you get it mounted on your fuselage, and add ballast as necessary so that the CG is where the assembly instructions say it should be. There's a little indication on the assembly drawing as to what that CG is, and this one is perfect. We need to do some final tweaking to our throws and such, but I'm really excited about going and trying this out, seeing how it flies. We are on Mount Zion. We have a Pica. This is a SoarKraft Pica with the 4-servo RG-15 wing. That right there, you know, it's variable wind as usual, but it's coming in at a good angle. It's like 5 to 7 miles per hour. So let's fly this. That's awesome! Check, that's awesome. Alright, here we got the rough gen with the 4-servo wing. So this is elevator only, but with awesome flaps. Up. So it's blowing at like maybe 4 miles an hour. It's really light right now, but it's coming straight into the hill, so we got a nice little bump out in front. Said very light conditions, but it's handling it pretty well. Weighs about 740 grams. Sweet! Okay, I parked it with all the other trash, but awesome!